All right, this is Unit 8, Lesson 5, screencast number 8, Tropical Cyclone Formation Basin. All right. Given that sea surface temperatures need to be at least 80 degrees Fahrenheit for tropical cyclones to form, it's natural that they form near the equator. However, with only the rarest occasions, these storms do not form within 5 degrees latitude of the equator, so they don't form right at the equator. This is due to the lack of sufficient Coriolis force. Remember, the Coriolis force is that apparent curvature because of the spinning of the Earth. Okay, and that is the force that is necessary to cause the cyclone to start rotating or spinning. Okay, so we're not going to have them forming right at the equator because we need a little bit more Coriolis force to be present. Okay, they are going to form near the equator. Once a disturbance forms and sustained convection develops, meaning you've got rising warm air, it can become more organized under certain conditions. Okay? A lot of disturbances don't become hurricanes. Most of them don't. But under certain conditions, we do get tropical cyclones to form. Okay? And not all tropical cyclones, by the way, get classified into hurricanes. It depends on their wind speeds and organization. Okay, if the disturbance moves or stays over warm water, remember at least 80 degrees Fahrenheit, and the upper winds remain weak, meaning winds further up in the atmosphere, then the disturbance can become more organized, forming a depression. So a tropical depression is sort of your first step. Okay. Okay. The warm water is one of the most important keys, as it is water that powers the tropical cyclone. So you need to pay very careful attention to that. What is one necessary ingredient for the formation of tropical cyclones? Probably more important than anything else. Warm ocean water. Okay. As water vapor, remember water in the gaseous state is water vapor. As water vapor rises, it cools, and this cooling causes the water vapor to condense into liquid that we see as clouds. And in the process of condensation, heat is actually released. Okay? So evaporation requires heat to be absorbed, and condensation releases heat. So this heat warms the atmosphere around the location where the condensation took place, making the air lighter still, because remember, if we're giving off heat, we're making the air around it warmer, and warm air is less dense. Okay, so the air is lighter, which then continues to rise in the atmosphere. And as it does, more air moves in near the surface to take its place, which is the strong wind that we feel near these storms. Okay, so we have water vapor rising and cooling. As it cools, it condenses. When it condenses, it actually releases heat back into the atmosphere, which warms the atmosphere, making it less dense, making things continue to rise. So it's sort of a snowball effect a little bit. Okay. Okay. Talking about the eye of a hurricane, for instance. Okay. Sorry about that. I got interrupted. Therefore, once the eye of a storm moves over land, it will begin to weaken rapidly, not because of friction, but because the storm lacks the moisture and the heat sources that the ocean provides. Remember that the ocean is providing all of the warm water that's necessary to fuel a tropical cyclone. Okay? This depletion of moisture and heat hurts the tropical cyclone's ability to produce thunderstorms near the storm's center. And without this convection, the storm rapidly diminishes. I think you may have observed or seen that once a tropical storm or a hurricane moves into the land, it basically dissipates and becomes much weaker because the warm ocean water is what it needs. And once it's not over warm ocean water, it can't sustain itself. Okay. All right, so your key ingredients, the one above all things that's necessary, is warm ocean water for the formation of tropical cyclones. Okay, this NASA image, it's not to the left, it's above, is Hurricane Wilma in October of 2005. The color of the ocean represents sea surface temperatures, with orange and red colors indicating temperatures of greater than 82 degrees. So you've got very warm ocean water in here. Okay. Wilma, as well as any other hurricane, removes heat energy from the ocean to provide it to the storm. This shows the purpose of tropical cyclones. Their role is to take heat, which is stored in the ocean, and transfer it to the upper atmosphere, where the upper level winds can carry the heat to the poles. Okay? This keeps the polar regions from being as cold as they could be and keeps the tropics from overheating. So you need to understand that a tropical cyclone, a hurricane, tropical storm, etc., removes heat energy from the ocean. Okay? Any hurricane, tropical cyclone, provides it to the storm, takes the heat stored in the ocean and transfers it to the upper atmosphere, where winds can carry it towards the poles. Okay. All right, now we're going to talk about how do we classify tropical cyclones. Okay. Tropical cyclones with an organized system of clouds and thunderstorms with a defined circulation and maximum sustained winds of at least 38 miles per hour, 38 miles per hour or less, are what we call tropical depressions. That was, remember, step one. So 38 miles an hour or less, and they are known as a tropical depression. And they're typically just numbered. They don't get a name when they're a tropical depression. They might call it tropical depression number 1 if it's the first one of the season, tropical depression number 2, etc. Okay? Now, once the tropical cyclone reaches winds of at least 39 miles per hour, they are typically called a tropical storm, and they are assigned a name. Okay? So it would become Tropical Storm Berto or Tropical Storm Cecilia, or what have you. Okay, so once they reach the tropical storm stage, meaning they have sustained winds of at least 39 miles per hour, they're upgraded to a storm and they're given a name. If maximum sustained winds reach 74 miles an hour, then the cyclone is upgraded to a hurricane. And remember, we call them hurricanes, but in other parts of the world they may be called typhoons or cyclones. Okay, but the ones that we pay attention to are the ones that are forming out in the Atlantic and the Caribbean, and those are going to be called hurricanes. All right, hurricanes are further classified according to their wind speed. Okay, so we go from tropical depression, less 38 miles an hour or less, tropical storm when it reaches 39 miles an hour, then if it reaches 74 miles an hour at least, then we call it a hurricane. Okay. But then hurricanes are further classified according to their wind speed. The Saffir-Simpson Hurricane Wind Scale is a 1 through 5 rating based on the hurricane's present intensity. This scale only addresses wind speed and does not take into account the potential for other hurricane-related impacts such as storm surge, rainfall-induced floods, and tornadoes. Okay, so please understand that the Saffir-Simpson scale is only addressing wind speed. Okay? All right. So I'm going to stop this screencast and then we're going to start with the Saffir-Simpson wind scale.